When you step outside during a storm, you don't just see the weather, you feel it. You watch the tall grass whip back and forth, you hear the rustle, and you brace yourself against the physical push of the air. But when we explore the outer solar system, we lose all of that. We send our cameras and our sensors millions of miles away, and they return stunning, high-definition pictures, but they arrive without any of the tactile reality of the environment they're capturing. We stare at the dry, rocky plains of Mars, tracing ancient riverbeds and dusty craters with our eyes. We know the wind is blowing out there, shaping the dunes, but we are completely numb to it. It leaves us with a sensory vacuum. It raises the question of how well we can actually comprehend a distant world if we're entirely cut off from the physical forces that shape it. That disconnect sparked a unique experiment, taking a stream of cold, abstract numbers beamed back from another planet and turning it into a physical force you can stand right next to. Artist David Bowen decided to build that bridge. He created a kinetic installation called Tele-Present Wind. The setup relies on a grid of 126 mechanical bases, each one gripping a tall stalk of dried grass. By tying this rigid machinery to natural earthly flora, Bowen built a physical conduit. It gives anyone standing in the gallery the chance to experience a true Martian breeze while remaining on Earth. The starting point for this breeze is located deep inside the Jezero Crater, right on the surface of Mars, with NASA's Perseverance rover. Strapped to the rover's mast is a suite of instruments called the Mars Environmental Dynamics Analyzer, or MEDA. It acts as a highly advanced interplanetary weather station. As the thin Martian atmosphere blows past, the wind physically interacts with MEDA sensors. The instrument measures the exact speed and direction of every gust, but those physical forces can't be bottled and shipped. Instead, the rover translates the pressure into raw digital code. That code is then packed up and broadcast across millions of miles of empty space, back to receivers waiting on Earth. The weather event has been successfully captured. The problem is, it arrives here trapped entirely in the digital realm, a spreadsheet of invisible data points rather than a breeze you can feel. Those incoming data packets land first at NASA's Jet Propulsion Laboratory in Southern California. Here, the project required a cross-disciplinary team. Rishi Verma, a data systems architect at JPL, and Jose Antonio Rodriguez Manfredi, the lead scientist for the MEDA instrument, teamed up with Bowen to decode the transmissions. They had to map that incoming stream of numbers directly to the grid of gallery bases. They built a system where the Martian wind vectors dictate the exact X and Y tilt of every single motor. The result is immediate. When a gust hits Perseverance on Mars, the data triggers the mechanical bases, and the grass stalks sway in perfect synchronization. This is where the engineering pipeline meets the artist's vision. Together, they take a weather event that happened on a distant world and resurrect it right in front of us. The technology found a public stage as part of a gallery exhibition called Blended Worlds: Experiments in Interplanetary Imagination, inviting anyone to step inside. There is a sharp, poetic contrast in the room. You watch the chaotic, natural movement of Miscanthus transmorrisonensis, a very earthly grass, being completely puppeteered by an extraterrestrial force. The exhibition designers call this approach interplanetary imagination. It uses art to give the public a tangible connection to the hard science currently being conducted across the solar system. Instead of observing graphs of wind speed on a computer monitor, visitors get to stand quietly and watch the ripples move through the field. They get to feel the rhythm of another world. Mars stops being an abstract point of light in the night sky, or a dry collection of rover images. It is understood as a real, dynamic place where the wind is blowing right now. This translation effectively shrinks the vastness between planets. When scientific data is expressed through the motion of grass, the Martian atmosphere is no longer a set of remote coordinates, but a physical experience we can finally perceive.